May, June 2024, paper 1, variant 3. A student wishes to find the volume of a small, irregularly shaped stone. Which apparatus is needed? Which apparatus do we need? Yes, we need the measuring cylinder. Okay, to find the volume, we need the measuring cylinder only. A car travels along a road at a constant speed. What correctly describes the speed time graph of this car? The speed time graph of this car, if I have a speed time graph and it's moving with a constant speed, then I would draw it as a horizontal line, line. This is the speed time graph. 4 objects are moving along a straight line. The distance of each object from a fixed point is plotted against the time. Which object is decelerating? Deceleration. Yes, deceleration would be, yes, exactly, it would be C. An object is taken from Earth to Moon. Acceleration is 9.8 on Earth. On Moon, it's 1.6. Which row describes the mass and the weight? On the Moon, what happens to the mass and what happens to the weight? The mass is definitely the same, yes, but the weight is D. Yes, the weight is less than on Earth, exactly. Question 5. Okay. D is wrong. D is wrong. In question 3, D is wrong. Okay, why is D wrong? Because this is moving with a constant speed in the opposite direction. So, for example, A is moving with a constant speed, right? Yes, it's moving. What about D? It's moving with constant speed, but in the opposite direction. So D is actually wrong. Okay, it's only C. Question 5. What is the density of the liquid? Density equals mass over volume. Okay, density equals mass over volume. The mass is 16 and the volume is 20. 16 over 20 is 0.8. A single force acts upon an object. Single force acts on an object. The volume does not change. Which statement is correct? Yeah, which statement is correct if you think about it? Question 6. Does the density change? Does the density change? No, the density does not change. Why? Because the volume is the same. The velocity, can it change? Yes, the velocity can change. The mass, does it change? No. And if the mass doesn't change, therefore the weight does not change. So it is B. 4 electric motors do the same quantity of work when they lift a weight of 10 newtons. What happens? The time taken are shown. What is the time for the highest power? As you increase the power, how can I increase the power? Power equals what? Energy over time, or work done over time. So to increase the power, you need to decrease the time. To increase the power, you need to, yes, decrease the time. Question 8. Which row describes how the pressure beneath the surface of a liquid depends on the depth below the surface and the density? Pressure, depending on, okay, pressure depending on the depth and the density. How does it depend on the depth and the density? As the depth, pressure increases, decreases or increases? Pressure decreases with increasing depth? No, it actually increases with increasing depth. Pressure decreases with increasing, no, it increases with increasing density. So they are both directly proportional. Which process does a gas turn into a liquid? Gas turning into liquid, yes, it is condensation. Okay. A pollen grain. Yes. What about the pollen grain? Pollen grain. This moves in a Brownian motion. So it's A. Okay. It is A. What is the relationship between Kelvin and degrees Celsius? So Kelvin isn't T. Here, Kelvin is T, and Celsius is theta. So we know that the equation is Kelvin equals Celsius plus 273. He wrote down Kelvin as T and the degrees Celsius as theta plus 273. Can I move the equation? Can I write it down as theta equals Kelvin minus 273? Yes, I can write it down. Okay, so it is B. Okay, it is B. Question 12. A famous experiment. Scientists showed that when water in an insulated tub is stirred, its temperature increases. Okay, its temperature increases. What can be concluded from this experiment? What can be concluded from this experiment? Temperature is a store of energy. Water absorbs heat from the surroundings. Work done by stirring increases the internal energy of the water. Energy is not conserved. No, we know that energy is always conserved. So D is wrong. Temperature is a store of energy. No, it's not a store of energy. The water absorbs heat from the surroundings. Actually, it doesn't absorb heat from the surroundings. It absorbs heat from the stirring of the water. Why? Because this is energy. This is a sort of kinetic energy. My kinetic energy is being converted, or it's being transferred as heat energy to the water. So work done by stirring increases the internal energy of the water. Solids expand. Okay, in which example is there a useful application of expansion and not an unwanted effect? Useful application of expansion. Which of these could be considered to be a useful application? Bridges, no, this is not useful. This is an unwanted effect. Railway, it's also an unwanted effect. Telephone cables, this is also an unwanted effect. The thermostats or the thermometers could be considered a wanted. We actually use the expansion of the liquid inside the thermometers. Okay? Conserved means that it's not lost. We say that energy is conserved, so energy is not destroyed. Energy is not destroyed. It's just transferred. This is the law of conservation of energy. A rod is made of half aluminum, half glass. Which statement is correct? Which of these pins do you think would fall off first? It's quite simple. Which of these pins would fall off first? Yes, it would be pin P falls off first. Why? Because aluminum is a better thermal conductor than glass. Yes, quite simple. Now, question 15. In countries where it is usually hot, houses are often painted white. What is the reason for this? Why do they paint their houses white in these very hot countries? White surfaces are good reflectors, good conductors, absorbers, emitters. No, we know that they are poor emitters, poor absorbers, and it has nothing to do with conduction. They are good reflectors, yes. What is the name of the distance between one crest, okay, from one crest to the next crest? It is the wavelength. Yes, it is the wavelength. Question 17. Waves on the surface of water travel from deep to shallow. From deep to shallow. Which diagram shows the correct path? Which of these diagrams shows the correct path? So as you move from deep to shallow, what happens to the wavelength? The wavelength decreases. Wavelength decreases. So C and D are wrong. C and D are wrong. Is it A or is it B? B is very tempting. I know that B is very tempting. Okay, but it's actually wrong. It's actually wrong. The waves bend, but they bend downwards. The waves bend, but they bend downwards. So it's actually A, not B. B is very tempting. I know B is very tempting, but it's wrong. Okay, why? Because, for example, if you have this wave, it's moving this direction. At this point, you need to draw a normal line. Yes, this is a normal line. This is the normal line. So the wave actually goes, it bends towards the normal line in this way, which is the same direction. What happened in B? What happened in B? If I continue this wave, and then I draw a normal line, if you draw the normal line, The wave in this example, it has not just that it has crossed the normal line, it has crossed the normal line, it went all the way to the other side of the normal line. It's wrong. It has to, okay, bend towards the normal line. Okay, it goes closer to the normal line. Goes closer to the normal line. So that's why B is wrong. It can only go closer or further away from the normal line in only 90 degrees. The angle cannot increase, or the bending cannot increase more than 90 degrees. It cannot cross the normal line. That's why B is definitely wrong. Okay. Again, in A, all you need to do is draw the wave. Draw the wave this way in this direction. Okay, this direction, and then draw the normal line. When you draw the normal line, what happens? This is the angle of incidence. What happens? It is bent. Okay, so it bends towards the normal line. It goes closer to the normal line, which is the same direction as this wave. In B, it has bent. Okay, it has crossed the normal line. It cannot cross the normal line. This is the normal line. صح? This is the. It cannot go all the way to the other side of the normal line. This is wrong in B. Hmm. Question 18. Okay. Does it increase the speed? Yes. Oh, in question 17, yes, it does increase. It actually decreases the speed when going from deep to shallow. From deep to shallow, it decreases the speed. Question 18, the diagram shows a thin converging lens, f1, f2. Okay, f1 and f2. What's happening? Which statement correctly describes the beam of light emerging from the lens? A small light source is placed at f1. A small light source is placed at f1. A beam of light from the source passes through the lens. Passes through the lens. So you have a light moving this way and a light moving this way, right? You have the light moving this way, right? It's passing right through the focal point. It's passing right through the focal point. If you have a line, if you have a ray passing through the focal point and then moving into the lens, what will happen to the ray? It will move parallel to the principal axis. It will move parallel to the principal axis this way. Parallel to the principal axis this way. So the beam travels parallel to the principal axis. Hmm. Okay. Again, again, what's happening? Again, what's happening if you have a ray passing through the focal point at f1? If you have a ray passing through the focal point, we have three rays. We said we have three rays. One of them was moving parallel and then it's bent and converges, passes through the focal point, the principal focus. This is the first line. The second line, which passes through the center, which is unaffected, it just passes right through the center, continuing in a straight line. The third line, third ray, if it passes through any of the focal points and it reaches uh, the lens, then it will move in a parallel manner. It will move parallel to the principal axis. Soon reads the following relationship in his physics book. What does the relationship mean, or what is this relationship for? It is the reflection, right? It is the reflection in a plane mirror. Reflection in a plane mirror. Yes. Question 20. Using the data, what is the frequency of orange light? Orange lights. We have Roy, Biv. So orange is between red and yellow, right? It's greater than red, but less than the yellow, which is around 5 times 10 to the power of 14. Greater than red, but less than yellow. 5 times 10 to the power of 14 hertz. Table gives the wavelengths of 3 electromagnetic waves. Which row correctly identifies P, Q, and R? What are the electromagnetic waves that we know? Okay. What are the electromagnetic waves that we know? Rami looks great, right? Rami looks great. Now, they are in the, yes, the radio waves has the longest wavelength, so for example we have what? Microwaves, radio waves, and x-rays. Microwaves, radio waves, and x-rays. That's all we have. The radio waves has to be the longest wavelength. Which of these is the longest wavelength? Times 10 to the power of negative 9. No, that's wrong. It's to the power of negative 9. So actually, this is the shortest wavelength. The longest wavelength would be r, times 10 to the power of 3, times 10 to the power. So this is radio waves. So the radio waves is the r. Okay? R is radio wave. So this is the only correct answer, actually. This is the only correct answer. Again, radio waves, and then you have microwaves, which is slightly longer. Yes, P, so this is microwaves. And then X-rays, the shortest wavelength. Okay, X-rays, which is the shortest wavelength. So it is B. How did I do it? Again, I immediately found the longest wavelength, which is radio waves. The longest wavelength, which would be the radio waves, 2.6 times 10 to the power of 3. A healthy human ear is able to hear a range of frequencies. What is this range? This range is from 20 to 20,000 hertz. Student hits two wooden blocks together and finds the speed to be 340 meters per second. The time between hitting the blocks and hearing the echo is 0.59 seconds. What is the distance between the student and the wall? This is an echo, right? This is an echo. So using an echo, speed equals what? Speed equals 2 distance over time. 2 distance over. To find the distance, it would be speed times time over 2. Speed times time over 2. Basically, you have the speed 340 times 0.59. So this is 100.3 or 100 meters. 100 meters. Diagram shows part of the magnetic field between two bars. Which statement about the ends of the magnets is correct? The ends of the magnets. So at X, it's moving in this direction. So X has to be North Pole and Y has to be a South Pole, right? C. X is North and Y is South. Okay. Question 25. Diagrams 1, 2, and 3 show an experiment to compare magnets 1 and 2. Yeah, magnet 1, magnet 2. Magnet 1 has W and X. Magnet 2 has Y and Z. The magnet on the scale, on the balance, is magnet on the balance is or the mass is 125.3. 125.3. Which row explains the readings on the balances? Which row explains the readings on the balances? When magnet 1 was close to the magnet, the reading it was 125, 124.9, so it decreased a little, right? It decreased a little. And then magnitude increased a little. So this one increased and this one decreased. What does it mean that it has decreased? That this reading has decreased. It means that it has been attracted, right? There is a force of attraction. So why does this one increase? Because there is a force of repulsion. So here there's a force of attraction, and here there is a force of repulsion. Force of repulsion. Therefore, X attraction means that X has to be a south pole. What about Z? Z has to be a north pole. Why? Because it has repelled. Therefore, it would be C. Okay? Which graph shows an AC voltage, an alternating voltage? Alternating means that it increases and decreases. It has to be positive and negative. The only one which is positive and negative is D, alternating voltage. There is a current I in a resistor for time t. The potential difference is V. What does the product IVT? IVT represents what? IVT, which is energy, right? We know that energy equals VIT, energy transferred by the resistor. E equals VIT or IVT. Soon designs a circuit to turn on a fan when the temperature increases. To turn on a fan when the temperature increases. Which of these components depends on the temperature? Is it A? No. B? No. It's D. Yes. The thermistor. The thermistor. 4 statements about safety when designing electrical products are listed. Which statements are correct? Which statements are correct? The outer casing is a conductor. It should be earth. If the outer casing is a metal, it should be earthed, yes, to prevent from an electric shock. The outer casing is a conductor. خلاص, this is wrong. If the outer casing is an insulator, it should be earthed. If the outer casing is an insulator, it should not be earthed. No, it's not a must. It's not a must. If it is a conductor, if the outer casing, for example, of your microwave, of your refrigerator, of your dishwashing machine, or whatever, if it's made of a metal, okay, if it is a conductor, then it has to be earthed. Why does it have to be earthed? To prevent from an electric shock. If it is a metal, if it is a conductor, so it has to be earthed. So one is definitely 100% correct. What if the outer casing is an insulator? Would the insulator pass a current? If you touch an insulator, will you be electrocuted? No. No, you will not. Therefore, it should not be earth. If the outer casing is an insulator, it should not be earth. So 1 and 4 only. B. Transformer has 400 turns on the primary coil connected to the 240 volts main supply. Okay, 400 turns. So this is NP. 240. Okay, this is VP. There are 2 secondary coils to serve different parts of a television. Secondary coil 1 has 2,500 turns. Secondary coil 2 has 20 turns. This is a nice question. So we will solve the voltage or the secondary voltage, but we'll do 2 times. 2 times. VP over MP. VP over MP equals VS over NS. Twice. Once when the secondary number of turns is 2,500, and the second time when the number of turns is 20. VP is 240 over 400 equals VS over 2,500. This is for the first time. Okay, coil 1. What about coil 2? Again, we will repeat the experiment. VS over 20. Cross multiplying in both equations. Okay, if you cross multiply in both equations, first one would be around 1,500 and the second one will be 12. Yes, the second one has to be 12. Okay, cross multiply 240 times 2,500 divided by 400, it would be 1,500. This is for the first one. And the second one, you have two, okay, you have two transformers. You have 2 transformers. You will solve the equation 2 times. That's it. A class is designing a DC motor to achieve a greater turning effect. 3 suggestions are made. A greater turning effect. Have a larger current. Okay. Have a stronger magnet. Or put a larger number of turns. What should you do? I think you need all of them, right? Larger current, yes, it would have a larger turning effect, a faster speed, stronger magnet, yes, and all of them, definitely. Which statement about the structure of an atom is correct? Atoms. Structure of an atom. Contains positively charged particles. What does an atom have? What does an atom have? Contains negatively charged, contains no charge. It contains positively charged and negatively charged particles. Yes, protons and electrons. A nuclide of strontium 90 and 38. What is the number of electrons and the location of these electrons? It has 38 electrons. Huh. They are surrounding the nucleus in the outer shell. Yes. Yeah. A radiation detector in a laboratory is measuring background radiation. Which row describes the readings and the cause? The background radiation. What does it cause? What causes the background radiation? Let's see. Vary with no pattern or slowly increase during the day. Does it slowly increase during the day? Or does it? Yes, it varies with no pattern. It's a random process. Random background radiation. Background radiation is random, unstable. No, background radiation is random. Question 35. The nuclei of the atoms in a substance are changing randomly and emitting radiation. What's happening to the substance? What is happening to the substance? What? Is it undergoing electromagnetic induction? No. Magnetization, solidification, decay, definitely. Yes, decay. What is the safest way to store a radioactive source? How can you store a radioactive source? Yes. Lead. Yes, a lead box. Which row explains the apparent daily motion of the sun across the sky and the phases of the moon? The daily motion of the sun. Earth rotates, the moon orbits. Does the orbit of the moon have to do with the daily motion of the sun? No, definitely not. Okay, so it's A or B. The cycle of the phases of the moon, the orbit, the Earth orbits the sun? No, not that the Earth orbits the sun. It's that the moon orbits the Earth once every month. Yes, the phases of the moon. The nearest the nearest star to Earth is 4 light years away. 4 light years away. Okay, this is a nice question. A spaceship travels at 0.1% of the speed of light. What is the total time taken, okay, for a journey from the sun to the nearest star and back again? This is a new and kind of difficult question, if you might say. Okay, it's a kind of difficult question. Spaceship travels at 0.1% of the speed of... What is the speed of light? We have to memorize the speed of light, which is 3 times 10 to the power of 8 meters per second. Right? This is the speed of the light. Okay, this is the speed of the light. So if the ship is traveling at 0.1% of the speed of the light, basically this ship is traveling at, let's say, what's 3 times 10 to the power of 8 times 0.1? It would be not 0.1, actually 1% or 0.1%, 0.1%, which is a relatively small number, 300,000. 300,000 meters per second. So now you have the speed. Do I have the distance? Well, if you have the distance, you do actually have the distance, which is 4 light years away. This would be quite a complicated, okay, this would be actually quite a complicated way of solving this question. Can I solve it in a much easier way? Yes, I can solve it in a much easier way. How can I solve it in an easier way? Okay, let's ignore this part. The distance between us and this star is 4 light years. Distance between us and this star is what is 4 light years. This means that the light, normal light, okay, normal light would travel in how many years? And it would take 4 years. It would take what? 4 years. Why would the normal light take 4 years? Because the speed of the light is 3 times 10 to the power of 8. It would take what? It would take 4 years to go all the way to this light. And then to come back, it would take another 4 years. So to come back, it would take 8 years. Okay. What if you have a spaceship that is traveling at 0.1% of light, which is 1,000 times slower, 1,000 times slower than the speed of light? 1,000 times slower than the speed of light. How long will it take? How long will it take? It will take 1,000 times more. It will take what? 1,000 times more. So basically, if you want to think about it this way, if you want to think about it this way, instead of this spaceship taking only 4 years to go to this sun, or to this to this star, okay, instead of taking only 4 years, it would actually take 4,000 years to go to the star. What about coming back? You need to multiply it by 2, so the total distance, or the total time taken, would be 8,000 years. Is this a normal question? No, it's definitely not a normal question. This is a tricky and yet hard question. Okay, it's a bit difficult. It is a bit difficult to think about this question. It is a bit difficult to think about this question. But again, okay, if I try to solve it quite simply, I would say that the light, which has a speed of 3 times 10 to the power of 8. Okay, distance. What is distance? Okay, isn't it the same distance? Yes, it is the same distance. It is the same distance. Distance equals speed times time, right? Distance equals speed times time. So it's the same distance traveled by light and the same distance traveled by the spaceship. So if you say that speed times time is equal to speed times time, the speed of light is 3 times 10 to the power of 8, and the time taken is 4 years. The speed of this spaceship is 3 times 10 to the power of 8 times 0.1%. What is 0.1%? Which is 0.1 over 100. Can I find the time? Yes, I can find the time. Okay, how can I find this time? By saying, well, we need to divide this. We need to divide this number by 3 times 10 to the power of 8, okay, times 0.1 over 100. But you just need to multiply it by 2. Why do I need to multiply it by 2? Because it will come back again. Sort of a reflection. You need to divide by 2, or sorry, multiply by 2, because it's sort of a reflection. Anyway, moving on. Question 39. In which regions of the electromagnetic spectrum does the sun radiate most of its energy? Most of the energy radiated from the sun comes from which sources? Infrared and ultraviolet. Most of the energy is infrared and ultraviolet. What is the approximate diameter of the Milky Way? Definitely, we know that the approximate diameter is 100,000 light years. Okay.